So today we're going to talk about uh, PyQt and how to create graphical user interface for Python. And there are many ways to do that, and there are several user interface toolkits. When I showed you the particle example in object orientation, that was the Kiwi toolkit, which is also an alternative. There is Take-Inter, which is a older user interface library that comes with Python. But we are going to talk about the Qt user interface, which is a large, it's not only a Python user interface library, but also a C++ one. So we go through the concept of what it is to create user interfaces and what you have to think about and what how you work with it. It will be a lot of code in the beginning, but at the end, I will show you a way how you can create user interface much more easy than in the beginning. But the beginning of the lecture will be more introduction, how you handle the classes in Qt and the kind of concepts around that. So the idea with user interfaces is to hide complexity. And complexity in this case is the situation we have today in computing. Is that we have a Mac platform, we have a Linux platform, we have a Windows platform, we have also phones, iPads, and that is really, and every platform has its own library for designing the user interface. So by using a toolkit, we can combine these. So if we look at the user interface on different platforms, I said you have an application. On Linux, you use X11 or Xorg or Wayland. There is a user interface toolkit that's specifically for Linux and Unix-based systems. And then you have the operating system beneath that. If you want to write an application towards Windows, you have to write towards the Win32 or WinRT APIs that are built into Windows. And that goes down to the Windows level as well. And then if you are on a Mac, you have to write against UIKit or NSKit. So you have kind of, if you want to have an application that works on all, you have to kind of write one version for each of these platforms. And this is not ideal. Some of the logic you can probably reuse, like the, what's it called? The application logic, like a simulation model or stuff, can be reused. But the user interface parts needs to be rewritten for every platform. And that's not ideal. So what we can do is we can add a middle layer. In this case, we have a Python binding here to something called Qt. And underneath here, we have a C++ library called Qt. And that library handles all that mechanism that you use to talk to the different platforms. So underneath here, you have all these libraries that is for a different operating system, but you don't have to care about that. You write towards Qt, and Qt will handle the interface for each platform. And to be able to use that from Python, we need a Python, something called Python binding, because Python is not cannot talk directly to a Qt C++ library. It needs to have a translation layer between the Python data structures and the Qt library, and that is called a binding. And to make life even more complicated, people in the Python community haven't been able to decide on which Python binding to use, which makes it, you have PyQt, we have Python for Qt, we have PySide, that are bindings available for Qt. But there is a solution for that, and I will go through that later today. It's called QtPy. And that is a really not super simple module, but that only purpose of that module is to detect which Python libraries are installed for Qt and hide that layer for you. So instead of importing PyQt directly, you import QtPy, the QtPy module, and that provides you all the modules that are part of either PyQt or PySide. So if you want to create really platform independent, you should always use QtPy as the layer between them. So coming back to Qt, so Qt is a platform independent user interface library. As I said before, it abstracts all the user interface concept in a single library. So we never need to call any native functions on any platforms. There's no need to go that deep. Qt kind of provides abstraction layer for all of these functions for you. And the nice thing with Qt, which is a bit different from other libraries, is that it actually adapts to the look and feel of the user interface on the different platforms. So if you're running on Windows, the application will look like a Windows application. If you're running on a Linux machine, it will look like a GNOME, typical GNOME or a KDE application. And on Mac, it will look like a Mac application. Even the menu will go up in the top on a Mac application. So if you have a menu, it will run in the window on a Windows machine or Linux, and then on the top if you have a Mac. It's also possible to add styled user interfaces by providing style sheets. So you can actually style it to your own liking. And another thing that is special with Qt is that all the events like mouse, keyboard is handled in a method called signals and slots. So a button can send a signal, and then you connect kind of a virtual cable to your methods or other controls. And that is called signals and slots. That is something we'll go through here as well. Yeah, I already covered this a bit, but Qt is a C++ library, and you need to kind of have a binding between those. And these are the bindings that exist. You have PyQt6, PyQt5, PyQt4, Qt for Python, which is called PySide. It's I think this is the official one binding for the Qt library itself. So they support PySide. Python Qt, I'm not sure, I haven't used that much myself. For everything in this course to work, we need to use PyQt6 because some of the graphical user interface tools needs Qt6 to work okay. There are ways of doing it in PyQt5 as well, but I would recommend staying Qt6. Before we go through a lot of code, we need to kind of go through what's the difference with a user interface library and a normal Python script. A user interface application is centered around something called an event loop. So basically, when you're running an application, a user interface application, it sits there just waiting for you to do something. So it will wait for a mouse event to click to occur. It will wait for a keyboard press, and then will continuously loop around that. And if something occurs, it will delegate that click or keyboard press to your code. And that is handled through the signals and slot. But basically, you start your application, and there is a function called loop or run that is blocking and will only exit when all other applications have or windows have been closed. So you can see you have the events going in here. You have a loop just waiting for the something to happen. And if something happens, it just says that, okay, this happened, please do something. And it calls your code. And this is a high-level kind of pseudo code for how this is not how it works internally. It's just kind of high level. So you have a flag here. So we initially say we are running. We check for events. So we ask the operating system, do you have any mouse clicks for us? Do you have any keyboard presses? Do you have window resize messages, or do you have a timer event? So it waits for those things. And if something happens, it returns an event, and then you check here if an event type is a button click, then we call some function to handle that click. And then you have multiple checks here like this. And then finally you have, if you have an event type that the window is closing or the application is closing, you set the flag to running is false, and then you exit this loop. And usually this stuff here is hidden inside an application object in Qt. So you basically never see this, but you call a method that has this loop internally. I already talked about some of these things. You have many bindings in Python. So what libraries to choose? Yeah, it's hard. It could be that you have a requirement. We are using PyQt5 in this. But then it's easy. Then you can use the Python Qt5 modules. But if you want to write your code in a platform independent way, we need to kind of handle that situation as well. We don't want to implement our own code for switching. So Qt it does this. So it checks for instead Qt bindings, and it imports these correct modules. And fakes the module tree for you, so that instead of using Qt5, PyQt5 as the prefix to your module, you use Qt-Py instead. And it supports multiple Python bindings. So a basic Qt main program, kind of the smallest thing you can do. You have on the top here, you have, like I said, from Qt-Py, QWidgets import star. So this is, if you have another binding, it could be said PySide 60 or PyQt5, QtWidgets import star. So in this case, you just do Qt-Py instead, and it handles that automatic translation. Here's our main program. The first thing we are going to do is we are going to create something called an application object. And the application object is responsible for handling the event loop, but also handling any command line options that you can pass to the application. It will also own your windows. The widgets and windows that you create will be owned by application. So we create that object first. Next, we need to create some kind of window. And the base window for Qt, the Qt library, is the QWidget. And QWidget is also the base class for all the controls. So if you create this QWidget object, it will create an empty window. So this will create an empty window, and then you do widget show, because otherwise it doesn't show up on the screen. If we would have stopped here, the application would close and the window would go away. If you don't do anything else or do a wait here, the window will lock up. So in the final part of the application, you have to enter the application loop or the event loop. And in Python Qt, you do that by calling app.exec parentheses. So this function call will block. It will sit here, and internally it will have this event loop. And the sysexit is just that if the application exited in an unusual way, it will return a return code. And then you can send that along in your application so that you can respond to that in scripts and so on. So if we go to, this is the first example here. No, this is one. This is just an application loop. Create a widget, and then sysexit here. So if we run this application, you can see already now it can do some things. So it shows a window, it says Python, because that is the default if you don't specify anything more. It can handle resizing like this. So that is built-in functionality of the QWidget class. You can maximize it, you can restore it, and you can close it. And you can look here, the application is sitting there in the Python call. And if I close it here, you can see it exited here. So now it goes out of this loop here. So this is the smallest application. This has no really use because you can't interact with it except for resizing the window. So I went through some of the object orientation before with you, and user interface libraries are kind of the best fit for object orientation with hierarchies, because you have a lot of controls that have similar functionality, so it kind of lends itself to inherited functionality. So if you look here, we have widget on the top. We can define our own window class here, and we can have groups here that could contain other controls. And we have the controls here on the bottom here. So this, when you design a user interface, you build up this object hierarchy, but QWidget is the base class for all of the controls. So QGroup is a QWidget, QLabel is also QWidget, QLineEdit is also a QWidget. So all of them are based on the base functionality of QWidget. And if you want an empty window, you can inherit from QWidget, and then you can rename it something yourself. And all QWidgets can also own their own multiple controls. So you can have multiple widgets in a window. So if you don't have any parent to a widget, it will create a window for you. And the usual design pattern is that you derive a custom application window from QWidget. So this is this one here. And this is how it can look. You have class my window QWidget. And then we have super init here. So we call the constructor of QWidget. We need to do that, otherwise it will not work. We can set some properties here. So we can set the geometry. That means that you can set the position, X, Y, 300 by 300, and width and height. We can set the window title here, and then we show the window here. So when we create a new window, it will automatically be shown. So we can do that here. So we have here our constructor for the QWidget control. We set the geometry and the title, and then we show it automatically. So in our main program now, we can just do window equals to my window. That will automatically show the window on the screen as well. And running this will produce something like this. So now you say it's my window here. You can also see that it started here at position 300 by 300, and I think it looks like it's 600 by 600. So looks okay. Yeah, this is the main program. I can put that on. A user interface kind of useless without any ways of interacting with it. So what you do when you have created a window, you probably need to you can have a, this is not correct. So the next part is that you have to create controls. And something that you will need to kind of consider is, are the controls necessary? Do you need to access the controls from other functions in your window? Sometimes you need to be able to update the controls. Then you need to make sure that they are attached to the instance here. So self button, that will be attached directly to the, so it remembers that control. You have a reference that you can go back to. If you just have labels and stuff that you don't need to access, you can just create label equals to, you can skip the self here. Because everything you create will be added to the window. So you can see here that you create a Q push button object. This is the title, and the final part here, self. That is the owner parent of this widget. In this case, it will be my window here. So when you do this, this is attached to the window and it's owned by the window itself. But it's not necessarily that you need a reference to it, but you need to set an owner, and you can skip the self if you don't want to that. So and then you can set tooltip, and that is when you move the mouse over a button, sometimes it comes up a hint box, and that is what you can set here. You set the size of the controls using resize, and then you can move it to a certain position here with move, and then you show here. So this looks something like. So now you can see here I have a button here on my window, and you can see already now if you move the mouse over it, you can see it has some functionality already. That's built into the class. So the class knows how to handle a button. And you can also see here if I leave my mouse over the button, it shows you this hint box. And that is useful if you have something that is it's not perfectly explainable. You can have these hint things to make the user understand your user interface. You should kind of make your user interface obvious enough that people can understand it without hint boxes. But it's a way you can add explanation in your code. So next, we have a button. We can press the button, but nothing happens. So to be able to interact with the user interface and your code, you need to connect the button to your code in some way. And every Qt control has a number of events or signals that can be connected to other classes or functions. So for example, the button has a clicked signal. So when a button has been clicked, that is mouse has gone down and up. That is a click event. And you can also have a pressed. that is an event that happens when the mouse button is pressed and held on this on the button. A list box could have a current row change signal. So when you change the row in the list, it will call this signal. And then you connect the signals to code or controls using the connect method. So for example, if you want to have the clicked signal connected to your code, you do my button, that is the object. You have clicked, connect, and then you provide it with a function or control that you want to the signal to be connected to. So just kind of more for explanation here, you have the object here. It has a clicked signal, that is this one here. And then the function kind of acts as a slot where you connect this signal to. So the control is the first part here. It has a signal property. And that signal property you can connect to a button function, for example, like this. So this is a slot. If you have a line, you can also connect a signal to a slot that is, for example, a set text, for example. So here you have QLine edit, text changed. You connect that to a set text slot. So the Q label has multiple entry points where you can connect your signals to. So here you have line edit, that is control. Text change to the signal. Connect is the method to kind of connect this signal to code or your own function. So where do you find information about available signals and slots? So there are some links here which gives you a list of all the possible classes in Qt. And you also have, for every class, there is a section with signals and also available slots. So in this case, you can look at and see how what available signals you can use. So if we go back here, so in this case here, I have my push button here. I want to connect the clicked signal to my own method. So in this case, you can see here I have created a method in my class called onButtonClicked, and I do self button clicked, connect, self. I need to use self here because otherwise it thinks that it's a global function. So in this case, I do onButtonClicked, and then this is the one here below. And click doesn't have any parameters, so it's just clicked and then self here. So no other parameters. And here we also have our line edit. So line edit is a control that you will be using in the assignments as well. So this is the most common way of getting information from the user. So it's a small control where the user can enter text. It's like a small text editor. And it has a property called setText. And here I display a message here where I display line edit text here. So you can return the text here using the text method here. So running this, you can see here that I have two controls. I have a text control and have a button here. So if I do here, hello Qt, and if I press the button here, you can see it brings up a message box with the text in the button here. So now I made a connection from the user interface to my code. And the key is here, find the signal and use the connect method from that signal to connect to your own code here. We are going to go through a lot of the controls that are available in Qt, but one thing that there are a lot of methods that are common to all controls. Those are part of the widget base class. And for example, there is a method called setVisible that will set if the control is visible or not. And you can also query the state by using the .isVisible method. So that will, if you set it to visible to false, then the control will not be visible on the window. There is also setEnable. And setEnable will, if it's set to true, you can interact with the control. If it's set to false, you can't interact with the control. So you can limit the what the user can do with your controls. And sometimes it can be useful to indicate to the user, this control is not available right now. Then you run your simulation, for example, then you set enable to show results, set that to true, for example. Focus is mostly used for kind of keyboard interaction, so you can set the focus on which control should have the cursor active. It's also possible to set focus to a button. You can use the arrow keys to move around the controls, and the focus determines which control has the current focus or the cursor. The control text are set by using the setText method, and you can query the current text using the .text method. So we will use the controls. So here I have an application here with 3 buttons. I connect the button 1 to self button 1 clicked, button 2 self button 2 clicked. And the first method here, when I click on that one, it will check if button 2 is visible. If it's visible, it will set visible to false. If it's not visible, it will set visible to true. And then the second method here, event method, we have check if button 3 is enabled. If it's enabled, set enable to false. Otherwise, set enables to true. So let's see how that works. So you can see I have 3 buttons. If I press me here, now this control is gone. I can't press it. It's kind of not there. If I click it again, it comes back. If I press the third button here, or the second button here, you can see here that this button is grayed out. I can't check it. Now I can check it again. So this way you can disable controls and prevent users from doing things that they can't do in a certain state. Either you can remove the control, set visible to false, or you can use set enable. Sometimes the set enable is a bit nicer because the user can see that there is an option to show the results, but we are not in the state that we can show the results, for example, for simulation. So it's always useful to give hints to the user. That we already did. We can also control how the windows will appear. And as I said before, we have previously just used the Q widgets to inherit here. There is a special class called main window, and the main window class is handles if you want your application to have a menu or toolbars and status things. It's hard to do that in a Q widget based window. So Q main window implements those stuff and handles that for you. And you can also change the style of your windows here. So this is old Mac Windows here. But for example, Qt window is a default window in the operating system. You can set the dialog window type. Then you have some other properties that changes on the window, like you can't maximize it or stuff like that. You can have tool that creates a smaller window bar. So I will. Start with a normal window. You have seen those before. You have a minimize, maximize, close. If I use dialog, you can see here I have a close, but I don't have a maximize. I can still resize this here, but there is no maximize, minimize. You can have a tool window. Then you have this kind of minimal tool window bar here at top and a smaller button here to close it. That can be used for example, floating tool palettes with that we have multiple tools for painting program, for example. And you can set that to float on top of other windows as well. It's also possible to control the when you start an application. For example, if you want to create some kind of kiosk application that you want the application to cover the entire screen, you can control how that is done using the Windows state method. So let's start with Windows maximized. So Windows maximized is just the equivalent of pressing the maximize button on the window. So running this here. So you can see here, now the window covers the entire screen. If you do the window full screen, you have to be a bit careful. You have to know your shortcuts, because you're running this will cover the entire screen, even the start menu and the top part of your screen. And you need to know how to exit that. And on a Windows machine, it's Alt F4, and I think it's Command Q on a Mac. So if I run this here, you can see here that I get the white screen. Sometimes you want to do an application that really takes over your computer, and that is, you can do that. So if I can do Alt F4, I will close back again. Another thing that is commonly used in most applications I have seen is to have a menu and have a toolbar. And in Qt, the menu and toolbars are handled in the same way, basically. So you have the menu bar is implemented the Q menu bar class, and if you're deriving from a Q main window, there is a main window, main menu bar already in the application, so you don't have to create it explicitly. Then you create Q menu objects, and the menu objects are, let's see if I can get this to work. This is the menu bar object. This is the top level menu. On a Mac, it will be on the top of the screen. The Q menu are each of these menus here. And then the items in the menu are something called actions. So, and the reason we have something different than a menu item is that the toolbars and menus share the same actions. So instead of re-implementing a method for a toolbar button, you create actions for that you share between the menu and the toolbars. You can also see that we are sharing the icons for the tool, but the menu is the same icons that we have for the toolbar. And the reason then you connect your methods to the action. So you don't create a specific event for the toolbar button. Instead, you connect the action to the toolbar button and the menu, so you don't duplicate code. Yes, so I will show how that looks. So here I have I start creating a normal window here. In this case, I derive from the main window because that has a built-in main window, a main menu object. So the first thing I do is I do create an action, and I create an action and connect that to my own method. So in this case here, I have my own method here, and the action has a signal called trigger. So it's a bit different than clicked here, but it works just like clicked on a button. And then I create a menu here. So I create a file menu, and you can see here there is a function here that returns you a menu bar from the main window. And I add a menu called file, and I get back a file menu object. And then I add my action to this file menu. And this looks something like this. This is the file menu object, and you can see there's only one action here. But you can see it took the shortcut and the text from my action object. And if I click this one now, you can see it shows you a message. But this way you can separate. If you have a toolbar, then you just use the same action here. And the action also handles shortcuts. So if you and that is something that you should think about, provide to power users, that there is a way of a keyboard shortcut that does the same thing as the menu item. So in this type you have Control T. So if I run this again here and I press Control T, you can see it did the same thing. Toolbars work almost the same way. So let's see here. Okay, sorry. I will do a bit larger example here. So I will come back to toolbars. So to show you how a complete application can look like, here you can see I have several actions here. You have new, open, save, exit, cut, copy, paste, and so on. And I want to create a menu structure from that. So here you can see I first create a file menu, add our actions, and then if you want to have a separator in your menu to kind of divide them in logical groups, you can do add separator. That will create a separator in the menu. Exit action. I create an additional menu here called edit menu, and then I add actions to that one as well. So if I run this here, you can see here now I have a more complete structure, window system here. And you can see that here you have the separator. Then we have the toolbar. Same thing here, you create an action, same thing like we did before. We create a menu, we connect our action to the menu, we create a toolbar, and here you can see here that you have an add toolbar method of the main window. You give it a name, add your action to the toolbar. You don't have to do anything more than that. You use the same action here, it should call the same. If you run it here, you can see here that now we have a toolbar in the window. And already now, without any much code, we can move the toolbar. We can put it down here. We can drag it outside. So if you press it, it also goes back here. So I can press it there. I can press it here. And now for the bigger example here, we combine this. So now we have a menu. Here are all the actions. This is not changed from the menu example. Here we create our menus, and here we create our toolbars. So we share the actions here. So no duplication of code. We have every action is connected to your functions, but they are combined, reused in the toolbar and the menu. So here you can see here I have a menu here, like this. I also have a toolbar. I think actually two toolbars. So I can, if I want, I can put one there and one here. And that functionality is built into Qt. So you don't have to do a lot of fancy code to handle that. That's built into the library. On the GitHub page, Compute Public, there is a UI Qt, and you have all these examples. So no need to write them down. Now the idea is that you can try them out yourself, modify the code. Yeah. Next, so up until now we have been placing the controls with coordinates in the window. You also called absolute positioning. There shouldn't be a zero there, but absolute positioning. You set the geometry, x and y coordinate, width and height. The problem with that is if you have a large user interface, changing the window size the controls will stay in the same position. It will not scale, it will not adapt. So what Qt has done to solve this is using something called sizers. And a sizer is a special control that the only functionality is to arrange other controls. So in this case here, you can see I have three sizers here. I have an outer sizer here that is a horizontal one, so it stacks controls in the horizontal direction. I have a vertical sizer here that is part of the outer one that stacks the controls on top of each other. By default, it has some margins between them as well, so it doesn't stack them close together. And here I have another horizontal sizer that is stacked together like this. So they automatically places control according to rules. So if the window resizes, it will move the controls according to certain rules. So in this case here, the simplest form here, I have created 4 buttons. I have a vertical box layout. That is one of the sizers. So what that does is handle controls in a vertical fashion. So it will stack them on top of each other. If the window resizes, it will distribute them evenly over the control. And then you so create this object, and then you add your widgets to this layout, and then you by default you tell the window that this is the default layout of the window. So let's see here. This is the code, my 4 buttons here. I add them to the layout. I set the window layout here. Because I have my window here, and now if I stretch this window here, you can see. But there's also a rule here. I can't make the window smaller than this because there's a rule here. There are minimum and maximum sizes of the control. So a button can't be smaller than a certain amount because it's depending on the font size. There is also a rule that says how much spacing there must be between the widgets as well. Next one is, of course, the other way around, and it works very similar to that one. So my 4 buttons again, and then I just add them to an H box layout, horizontal box layout. Looks something like this. So now it stretches them in the horizontal direction. You can also see that it stops here. There's a minimum size of the buttons here that is enforced. But you can see I didn't have to program anything of this. This is built into the library, and you don't have to think too much about it. And now, of course, it's very hard to build a user interface of either a vertical box or a horizontal. You need to kind of combine them into a user interface in some way. And what you do then is that you can combine them in any way you want. So in this case here, I have a outer box that is a vertical box. And I insert a horizontal box into this control with a set of horizontal stacked controls. Then there's also a possibility to add springs. So suppose I don't want the controls to be kind of spread out evenly. I want them to be on top of the window. I can add stretch. And that acts as a spring here. It will push the controls apart. So let's see how that can look. Here I have 8 controls, and I add the first controls to the vertical box. I create a horizontal box where I add my other 4 controls. I add a stretch in my vertical box, and then I add a layout to my box here as well. So the H box is a layout, so it's not a widget, and I add it to it, and I set my main layout here to be vertical box. So now you can see if I run this, there is a gap between here, so it pushes these buttons on top. And if I drag down here, you can see it. You can see here. You can see there is a virtual spring here that pushes the controls up on top. And you can do the same thing in the other direction as well. So in this way, you can design your user interfaces by combining vertical boxes and horizontal boxes. And my recommendation is before you code user interfaces, use pen and paper and draw, or use Figma or something to kind of design your layout, because it's really hard to kind of design in code. And I will show you at the end, as I said before, that I have a tool that is even more efficient at doing this. But I think we'll take a 10 minutes break, and then I will continue the controls. So horizontal and vertical sizes we have. There's another one that is a bit more flexible. It's called a grid layout. And it is a layout you add your buttons according to a row or column grid. So here you have button 1, 2, and 3. They are placed in a row. So you have 0, 0 here, 0, 1, button 3, 0. So rows and columns. That can be some flexible sometimes if you have some kind of layout in a user interface that requires that. Here you can also add springs, other stuff into to decide how the relationship between the sizes will be as well. I think it's better to show it in the code still. Grid like this. I have my 9 buttons now. And here you can see also you can set how the control should be sized. In this case, expanding. So you want the controls to be able to fill out the entire space. By default, the buttons is expanding in the horizontal direction, but it's limited in the vertical direction. And by doing this here, the buttons will expand in both directions. And here you can also see that I have, when I create the grid layout here, I add a widget, but you also have 2 parameters here, which is the row and column, not the coordinate column. So it's kind of just like a matrix row and column. Here you can also set the contents margins. That is the margins that is around the controls. Here you can set the horizontal spacing between the widgets. And here you can also see that you can set stretch factors. I will show them later here how that looks in the final layout as well. So run this here, you can see I have a grid here of 9 controls. And if I resize here, you can see here that they resize in different ways. And the reason we have different sizes here is the stretch factors. So you have column stretch here, you see here column 1, 2, and 3. You have a 4 here. That means that the first column is sized to 1, and the second has a size of 4, and the third one has a size of 1. That is the relationship between them. So it's not any units of, it's just how they relate to each other. So if I, for example, set 1, 1, 1 here, and 1. You can see here now they are equal in the column side. I can do the same thing here with this one here in the row direction. And now you can see they are stretched equally. You can also set, if you change the content margins here to 0, you can see what that affects. This is the outer, how much spacing there should be outside the grid control. So this is this spacing here, and on the top here on the bottom, like this. The spacing here, this is the spacing between the widgets. So we do 5 high here. You can see that the spacing between the widgets are smaller here now. So this is many ways you can control the sizing here. So just see if we can just comment out here what happens if we. So now you can see here the button 2 here. By default, it's expanding in the horizontal direction, but it's not expanding in the vertical direction. So this is how you can control that as well here by using the set size policy. And of course, you can combine the grid control with vertical box, horizontal boxes, but you can put them inside here. So you can nest them how much you want to create your desired control. So it's flexible layout sizer. Standard dialogues. In many cases, you have very simple needs of your application. For example, you want to ask the user, do you want to delete this file or not? So yes and no. You want to show a message. You want to ask the user for a file. And you don't want to implement these user interfaces in Qt yourself. So what many of the operating systems today, they actually offer you standard dialogues that are built into the user interface library underneath. And you have the categories. You have message dialog, file dialog. So it's also for selecting colors. And these can be reached by using functions in Qt. And they often call the underlying operating system's function. So they look and feel like you're running on Windows or Mac or Linux. I have here an example with a lot of buttons here, but you can see here I have information, warning, critical, question, open file, and save file. And to use these controls, you need to import the widgets and core, and then you have you don't need to instantiate an object to do this. What you do is that you use the module QMessageBox. You call the method information. You need to provide an owner of the window that comes up, so you will attach it to your main window. Then you have a title, and then you have a message. That will bring up a message box. The information function will not return until you press the button OK or something in it. There's also this question dialog. It has a function here. You provide it what buttons it should display. So in this case, I want to show yes, no, and here also the final one is the default answer. So if the user doesn't select anything, it will return no. And you can also, if reply is yes, then do this, otherwise do this. So the reply here is what the user answered. So let's try them out. So if I press information, you get this one. Warning, you get the warning triangle. You also get a different noise here in Windows. The thing is that use the critical and warning a bit sparingly in your application. I mean, critical kind of sends chills up your user's spine if you send it, and also because something really bad happened. Warning is also a bit like, oh shit, something happened. This one is kind of neutral. And also the question one here is good if you, for example, want to ask the user, do you really want to overwrite the file or do you want to delete this thing? You can use this question system here. So here you can see here, the default option is marked here. So if you don't do anything, it will say no. And it answered yes. So question is also a very useful function. Another thing that you will do in your applications is ask the user for a file. It's a very common operation, and there is a dialog for that as well. So you have qfile dialog, get open file name. So that asks the user for a file, and it returns a file name. If the user selects cancel, the file name string will be empty. There is a second parameter here which we don't use. So if you have a function that actually returns two parameters, a way that is a kind of common pattern in Python is that you put an underscore on that parameter. You don't care about it, so you set an underscore. It will work like a variable, but you kind of just ignore it. So let's see what happens if you run this. Open file. Now on Windows, you will get this standard dialog box which is the one that is built into Windows. If you're running on a Mac, you will get the default file selector for a Mac, and the same thing on Windows. So if I select here, press open, you can see here you get the full search path of your file. So you don't have to do anything. It will be the complete file path. Save file is very similar, but it asks you to create a new file. So open selects an existing file. With save file, you have to enter a file name. But it's the same kind of dialogue, so let's look at that. So here you have to enter a file name, anything, something like this. And In this case here, I don't have an extension, but you can also specify an extension, and then it will add that extension to your file as well. So here you can see it's selected the file. So don't create your own dialogues for these simple things, and check if there is standard dialogues for certain common things. And for example, if you want a user to select a color, there are color dialogues as well. Font dialogues, a lot of them. I'll skip those. Yes, then we come into the controls that you want to interact with the user. That the user should give you information about, for example, your computation model has some input, and the user has to provide them in different ways. And you communicate with the user using controls. I will go through some of these here. Checkbox radio buttons. A checkbox is a control that can be either checked or not checked. You can have as many of them as you want. You check them by using set check state, and you can query them using check state. You can also there is a radio button as well, and radio button is a bit special because it's if you have multiple radio buttons on a single window, only one of them can be checked at the same time. And if you need to kind of have multiple radio button groups, you need to group them, otherwise you can only have one of them in total. If you want to have two option groups, you need to put them in user interface groups. Let's see how that looks. Control checkbox. So here you can see I create a checkbox here. I use set checked here to set it to true. There is also a signal called state change that you can connect. I would say that for checked and radio buttons, you really don't need to connect signals, because you can always query the control at some point in your code. Is it checked? Is it not checked? So it's not necessary to have these kind of controls. I will come back to how you handle controls also in a more structured way. But there are signals that can handle the change. So if you run this, you can see here that I have a single checkbox here. And now you get a message box because it is connected to the signal state change. And you can see here that it's checked. And if I press 1 again, it is it checks. Okay. Yeah. So is checked to check the state and nothing. So this is the usual way. Radio buttons are a bit. So here you can see radio buttons. They work like checkboxes, except that they are aware of each other. So if you have two of them, only one of them can be checked at the same time. Like this. And they also have, in this case, we have a clicked state connected to them, but you don't have to do that as well. You do the same thing, is checked. And if you need to kind of have multiple groups of these, you can add them to groups, and then every group works independently of each other. But if you have just radio boxes, there's only one group in the window, so only one of them can be active in the window at the same time. Combo box is a multiple selection control, so and also text box. So you can ask the user for a set of limited options that you can describe in text. You can also have a text box on top. That is also something you can turn off. So it can act as a text box as well. And the idea of using this is when you have not so much room in your window, you can hide a lot of complexity by providing information in a drop-down box. The currently selected item can be queried using the current index function. And there's a signal called current item changed that is called when you change the combo box. So here you can see I create a combo box here. I add alternatives here. So these are the selectable options that I can add to the combo box. I set the current index to 3, so 0, 1, 2, 3. So the number 4 here will be selected by default. And then as you can see here, I can do current index changed. And that will be called every time the selection is changed. And I just print out. And you can see here that this signal also provides an index parameter. And that is to indicate which option has been selected. So you can see they look like this, and if you pull them down, you can see that alternative 4 is selected. If I do that, you can see that you selected 1, and you can also query the text of that. So the current text is the text I've entered here, and the index is the selected item. In the compact control, that you can provide a lot of different combo boxes with different options. It doesn't take much room in the window. Slider is a fun control if you're designing audio mixers, or it's a simple control for providing fast numerical input. So it looks something like. So here I create 2 sliders, one a vertical slider. So you can set, the first option here is if the slider should go up and down, or left and right. And you can see you can also set maximum and minimum values. However, it's always only integer. So if you need a floating point, you need to kind of convert from an integer scale to a floating point scale. So this is somewhat of a limitation. It sends out a signal called value change. So every time the slider is moved, it will call this method here. So here I have I just print them out, the values of each slider. Running it looks something like this. So these sliders will look like it's a slider on a Mac, and here you can see the slider on a Windows machine currently. So you can see here if I change it, it will call this method, and the same thing here. List box is like a combo box, but will always show all options. So for example, if you have a lot of things that the user can select from, you can fill a list box and the user can select either single selection, which is the default, or you can also ask the user to select multiple things in the list. You can also, if you have more items than fits into this list box, it will add scroll bars automatically. So if we go to the list box here, you can see you have a widget here. It's certain size, and then I just add 100 items to the text to list box, and you can also see that you add a text here. Same thing, you can set current row. You can also, there is a current row change signal that is sent when you select something in the list. You've probably seen this in multiple programs here. You can scroll really quickly through. If I click here, it says what you selected, and also you can see the text, just like you have with the combo box. Line edit, we already were kind of covered that. This is if you have a simulation program or you need to be able to ask the user for values or text or something like that. And line edit is the go-to control for that. However, it can only handle text. So you can only set text or get text from it. So if you have floating point, you need to do a conversion, which I also will show later here in this lecture. So line edit. So you can set text here with set text. And then you can get text with a text method here. Really simple control. You can edit as much as you want. You can space here, and then you can get the text back from the control like this. So then you have to do some floating point conversion in that same to get the floating point value. You also have to do some error checking that, because there is no default floating point control. So then you have a set of tools to create user interfaces now. There are some other controls as well that you can use, but these are the more important ones. One thing that I always kind of press when you in this course is that you need to separate your user interface code from your computational models or any other code. But it could come a day when you need to do a web interface. And then you code that completely differently, but your computational model will stay the same. And you don't want to mix computational code in your user interface code. So you need to create some kind of way of handling that. It's not that you need to kind of interact with them, of course, but you need to separate your computational code or models from your user interface in some structured way. So this is where I'm talking about models and the user interface. There is a common concept in user interface design called MVP, MVC, Model View Controller. And that is that you have a model that is what your kind of the user should manipulate. That is an abstract model of your simulation problem or anything. And then you have a view that displays that model, and you have a controller to interact with that model. And those are separated. So the model doesn't know anything about the controller. It doesn't know anything about the view. So you create them as separate classes and create them together. So what I usually do in my user interface code is the first step is that I have create two methods in my window class. One, it's called update controls, which takes the values from a model and populates the controls with values. And then I have an update model that goes the other way around, takes the control values, convert them to floating points, checks the input, and updates the model. And then in the model, you also implement functions like reading a model from disk, creating a new model, initialize a new model. So you basically, all the functionality of your application you kind of implement in your model, and then connect that model to the user interface. So just to kind of make it really simple here is a simple model. It has some variables here, different types. I have a printing routine here to be able to print the model. I create a user interface where I represent all these model values with controls. And then I have an update controls that takes the model values, reads them, and sets the value. So in this case, I have text edit, set text, value edit, set text. And here you can see I do a conversion here if it's a floating point to a string. Option check, set checked, set value. And then if you have alternatives, you need to kind of check what values are set and then check the correct radio button in this case. Update model goes the other way around. You have to set the text value. You just go the other way around. Model text value equals to text. Value equals to float. So I need to convert here to floating point. Also option here that is a true and false, so that's no problem. I can assign that directly. But then I have to check here which radio button is checked, and then I will set the alternative to the correct value. So now I've collected in two methods a way of connecting the model to the user interface and vice versa. So it's not spread out over multiple event methods, two places in two directions. So to be even more concrete, I'm going to implement a simple supported beam. So the model for that is really simple. These are the formulas to calculate the section forces, the deflections, and the moments of that. And these are the parameters here. So the model will need to be able to store A and B as the input values, and the force here. So there's two parameters. And this is how I want to be able to use the model. So I want to create a beam object. So beam simply supported, that is my class. It implements the model. It has some properties here. So A and B, P, some material properties. And then I want to loop over to calculate different values at certain points of the beam. I do print, and you can see here x. I have a function called v for deflection, uppercase V for section forces, and M for moments. So, but it's a simple interface. It does all the computation internally, and here is the way you can use it. There is also a beam.L property that is the total length of the beam, which is an internal property that is calculated from A and B. I will show you here. So here I implement all my properties here as private variables. I give them some certain standard values. I calculate L here as the initial value is A plus B. And then also I need a way to converting from string values to floating points. And here I have created a method called toFloat. It takes a new value, that is the incoming value. I have the old value here as a kind of a last resort. So if the conversion fails, I still have the old value. And then I do a try except. So B equals the float. I try to convert. If I have a value, I return the old value. If the conversion were correct, I return the new value, converted value. Then I can implement my properties. A bit difficult to see here. So I use this property decorators. A is simple here, so if just want to access the A property, I just return self A. The setter is the more interesting thing. So in the setter here, I have a value coming in, and then I do self A equals to self toFloat. B is the new value, self A is the old value. So if this goes wrong, it just returns A here. So nothing will happen. But it's really robust. The user can't crash the program by having this here. And then I have this, I do this is something I do myself here because I think it's annoying to write self._. And so I do ABL equals to these one here. And that is perfectly okay because these are references. So then I can do more compact expressions like this. And then I implement these functions like as well. And this is the user interface. I enter the methods here and then I plot here. And then I use this in my, so here you can see the separation. I have a complete separate module as a Python file that contains the model. And then in my user interface source code, I import my model here. And then I create, when I start my application, I create a Beam object that we will use for computation, initialize the GUI, I update controls, and I update my text edit here. And then here I create my user interface controls. And then also I have if you have an edit box here, there is an edited finish connect, and that will always be called when you have entered a value and it will automatically update. So here you can see I have update controls with set text string self beam A, and then I will have update text edit here that will fill the text box with a table. It will clear the text box and I will append the format here, and then I will loop over here and calculate. And here I have self beam A equals to self A edit text. So the interesting thing here with my property design with the try float, I don't have to do any conversion here. I can just assign a text because the conversion will happen in the float try float. So it's really interesting, simple construction. And here I have unedited text finished. It will update controls. So I will show the application here. This application is also contained in the folder. So if you look here, I have the beam model here. You can see I set the initial values in the constructor. I have my functions for calculating the different things that I want the model to handle. I have my toFloat routine here, and here I have all my conversion properties. And here's a test function here as well. And then I have my Beam UI. So here in my Beam UI, the first thing I do is I create a Beam object, set up my UI. There's a lot of things here. Update controls. I have update text edit, and I have update model. And on edit things, so every time you do something in the controls, it will update the model and update controls. So let's see how it looks. This is how it looks. And the interesting thing here is if I do like 1.2 and I press tab, you can see the table automatically updates. So every time I leave a control here, on edit and finished is called on that control. You could have a button that does this as well. But so you can see every time I do something, it updates live here. So here I separated my model into a separate module, and I have my Beam user interface in a different one here. I also updated here a bit to handle, instead of having a text box here, I have actually a real table. So this is looks like more an Excel sheet. I have this functionality. I can sort them out. I can also sort in different sizes here. This is also part here, and this is also implemented here as a separate model. So now I show you how you can do application from scratch by coding the user interface yourself. But it's actually possible to do this in a much more easy way to create user interfaces. So in PyQt5 and older, we used a tool called Qt Designer, and I actually have the wrong thing in my slide. It should be, let's see here. Qt Creator. So Qt Creator is not only a design tool for user interfaces, it's actually a complete development environment for C++ and Python. So you can use that if you want as well. But if you create large applications, it can be a lot of code to implement all the controls manually. You have, for example, hundreds of menus. Every menu has to have an action. All the buttons you have on your Windows need to have you have to create them programmatically. So in Qt Creator, there is a built-in user interface designer that can generate a user interface file that you can load in your application and create all the controls automatically. So UI files are XML, which you can load in your user interface code, and then those objects are instantiated automatically. There is also another option which I don't cover here, is that you can also generate classes so that you don't have to provide a UI file for your application, that it creates a standalone class with all the controls created. So the idea is that you, just like normally you create your user interface here, but instead of where you have all the control creations here now, you do UIC load UI, and then you give it a file name and self here. That will create all the controls directly in this class, and they will be available like this. So I will show you how you do that. I have my Qt Creator ready here. So it looks something like this. This does much more than this here, so I will try to avoid showing everything here. So instead of, there should be file, new file. So do not go to new project, go to new file. And then you go down to Qt here. And then you want to select designer form, not the class here. This should be a UI file like this. Select. And here you can see what the main class you want to create here. So in this case, I go with widget, but you can also do main window, dialogues, and it will create buttons for you automatically. So widget, next, and then I will make sure that I put it in the wrong directory, right directory. I will call it form 1, Form UI like this. Next. Next. Yep. And now you get something like this. So on the left side here you have controls that you can select. On the right side here you have the object hierarchy, and you have a properties area. So what I do when I start designing in Qt Creator, I just drag the buttons over that I need. So just drag, drop, drag, drop, drag, drop. Just like approximately where you want your controls to go. So in this case, I want to have 2 columns here, something in the middle, and a row underneath here. So I just do like this. And you can see here on the right side here that you can see the objects being created. So these are the objects that you can create. If you select the button here, you can see that you can also get the properties here of this object. So in the beginning, the first property here is the name, and this is an important object to use, because this is the name it will get in Python. So if you want to program it, you need to select it here. So I will give this a push button like that. There are many other things you can set. For example, here the first parts here, the yellow, these are the common ones that are part of the widget base class. The longer you go down in the property spectrum, you will get more specialization in the hierarchy. So first is from the push button here, so I can change here my button, and you can see it changes in the control there as well. And there are some other things you can select here as well. So now this user interface looks kind of awful, so I want to make sure that I have a layout here. What you can do then is you just select these 4 here. For example, I want them to be vertical sized, and you can go to this one here, which is a layout vertical button. If you press that, you can see here it creates vertical aligned buttons. I do the same thing with these ones here, vertical, and these should be horizontal. And then I want to have a image here in between here. So I will, and that's something you can remember as well. There is a control called label. Looks something like this. You can use this control to put text in the user interface that the user shouldn't interact with. It's just a kind of placeholder text. But it can also handle displaying an image that you can load from disk. So I select that one here, and I go down, and I select Pixmap here. And then I choose File, and I have a Python logo here. So let's put that Python logo in here. And you can see there is a Python logo here. I want this to be in the middle here. So now these controls should be aligned horizontally. So I select all of these. And then I do like this. I didn't know where the other one. No, I selected too many controls. That one, and that one should be okay. I need to. The image was a bit too big, so I'll move that down. It would only be buttons that would be easier. And then I move that up here again, like that. So we can set the size on it. And then I put this here. And then I can select the layout for the entire window here to be vertical, like this. So now I have controls on the left, controls on the right, and it kind of looks really awful. So I want these buttons here to go underneath here. So then I can go up here and find my spring. And I put this here inside here. Oh, wrong. Delete. It should go into here, like this. So I push this up. Now I can push this one up here like this. And then I want these buttons to go on top as well. So I go in here and then I put the springs inside here. I save this. Now it's a form UI. And I go in here again and let's see here, controls. Yep. Now there. So I have these controls. I have form UI here, load UI. It will load all these things in my the UI file. Let's see how I save this one, yes. And if I run this one here, okay, push button 1, I have the wrong, like this. Now you can see here that I changed the text of that control and it created a user interface here for me from this UI file. So you can see here that you save a lot of code by using the Qt Creator tool to create the UI file. And that was I wanted to show you today. On Thursday I will go through a bit more sophisticated example from scratch. But I think you have enough information for today. So thank you very much.